All right, so we're going to do a quick little unit here before the end of the term. Unit 13, well, I don't know, chapter 13. We're going to talk about the volume of cylinders, the volume of spheres, and the volume of cones. All right, so we're going to start out with cylinders.
Oh, I remember doing this.
Yeah, good. This might be familiar to some of you. Some of you may have found like the area of these shapes before, but maybe not necessarily the volume. So let's go ahead and see what we're going to do here. Before that, actually, let's talk about two vocabulary words. Can someone read out the first one for me? What's that first vocabulary word? Radius. Go ahead, Noah.
Radius. A straight line from the center of a circle to the edge.
Exactly. A radius is just a straight line from the center of a circle to the edge. So if we draw ourselves a little circle up here and make a dot right in the center of our circle, or at least close enough to the center, our radius is this line here. That's called r. It's the distance from the center of a circle to the edge of a circle. Now, it doesn't matter where you draw this line, because every single line that you draw is going to be the exact same amount. If we drew a line over here, that line is also r. It's the beauty of a circle. All right, so that's one piece of information that we're going to need in order to find the volume of a cylinder. Can someone read out what's the second vocab word here that we have? Go ahead, Azalea.
Pi, mathematical constant equals to 3.1459265.
Exactly. You see those dots going on forever. Would that mean that this is a rational number or an irrational number?
Irrational.
Irrational. That's right. Pi is an irrational number. And the symbol that we use for pi, a lot of people draw it differently. All you really need to do is that. That's like probably the simplest I can make it for pi. It's a line with two little dots. It's kind of like a capital H without the top half. See what I mean? Maybe. So a mathematical constant. All that means, that's kind of a fancy way of saying it, but all that means is that this number does not change. Tomorrow, pi will still be equal to 3.14159265389 and so on. And we're going to use pi in this formula. Let's figure out how we're going to do that. So, to find the volume of a cylinder, you need to know two things. You need to know the radius of the cylinder, okay, the radius of the cylinder, and we need to know the height of the cylinder. We need to know the height of the cylinder. Once we know those two numbers, we could just plug them into this formula here. V is equal to pi r squared times h. That's our formula here. I made it nice and big and bold so that we can find it when we're looking through our notebook. Now, in this formula, what does r represent? It represents the radius. That's right. The radius. And what does h represent?
Height.
The height. Exactly. What does pi represent?
3.1.
Exactly. Pi represents 3.14159. But we just say 3.14. We'll leave it at that. So, we only need to know two things, the radius and the height. Let's take a look at this cylinder down here. Here's a cylinder, right? It kind of looks like a Pringles can. That's one way we can think about cylinders. Okay, it's got the little guy with the mustache on it. Looks like that, I
I
think.
believe that's
Whoa.
the outdated version.
Oh, is it? I don't know. I'm not hip on my Pringles designs, but that's kind of just, one way one instance of cylinders that we see in the real world, right? A Pringles can, even like a soda can, is kind of a cylinder. Most of it is a cylinder until you get to the bottom and top part. But We see cylinders all around us, right? Are there any cylinders in this room that you guys see? Take a look around. You guys see any cylinders in here?
My arm.
What'd you say, Theo?
Right there.
This?
Yeah.
Yeah, this microphone right here that I'm touching. This is a cylinder for sure, right?
The cup.
The cup?
Yeah.
Yep. This right here. It's kind of it's a little bit more tapered on the bottom, but it's close to a cylinder. Yeah, definitely. I don't think there's any more, is there? I don't see any others. I don't know about that one.
Yo.
That's not very nice. All right. Anyway, so just think about a Pringles can when you think about a cylinder. So take a look at this Pringles can. What is the radius of this Pringles can?
2.
2? Why do you say 2, Theo?
2 yards. Right there.
It says it right there, exactly. But how do we know that the radius isn't 8 yards? It says it right there. It says 8 right there, right? How do we know that the radius is 2? Jordan, you want to help us out?
Because the height is 8.
How do you know that 8 is the height, though?
Yeah, okay. Because
Don't overthink it. Where is 8 located?
oh yeah, because of the line. I forgot. Like the line shows you in the radius.
Yeah, there we go. Exactly. Now take a look. This 8 yards, this is right next to our height, or this side of the Pringles, this vertical side of the Pringles can. And this little 2 yard, it's got an arrow pointing to it. And that's the distance from the center of the circle to the edge of the circle. If we take a look back up, that is the definition of a radius. A straight line from the center of a circle to the edge of the circle. So we know that our radius is 2, and we know that our height is 8. Let's take a look back at our formula for a second. Ignoring this half and ignoring this. Where have we seen pi r squared before? Does that sound familiar to anyone? Where have we seen pi r squared before? It's a formula for something. What's it the formula for? Does anyone remember?
Area. I don't know.
Area of?
Of a circle?
Exactly. It's the area of a circle. Pi r squared, right? That is the area of a circle. And think about a cylinder, right? We have a circle on the top and a circle on the bottom, and it kind of looks like we just extended that circle. You can kind of imagine if I had a slinky and pulled that slinky and extended it. You okay?
Yeah.
Okay, let's calm down. If you had a slinky and extended it, that's essentially what we're doing here with this cylinder. So we're finding the area of the circle, and then we're going to multiply it by how much we extended that circle. If that doesn't make sense, the add puzzle will definitely clear it up. It's got some nice visuals that go along with that. So pi r squared, what was my r again here?
Radius.
Radius, that's right. What number represents r in this problem? 2. Times the height,
8.
which is 8. Exactly. Max. So let's think about solving this with PEMDAS in mind, right? We obviously want to solve what's inside the parentheses first, but all we have inside the parentheses is a 2, so there's nothing to do there. What's the next letter of PEMDAS represent?
Exponent.
Exponent. So let's go ahead and clear out this exponent here. 2 squared, that's 2 times 2,
4.
which gives us 4. Exactly. Times 8. Times 8, and then we got pi in front. So just like that. 2 squared is just 2 times 2, right? 2 times itself. And that gives us 4. So now we've got pi times 4 times 8. Now take a look at this note at the bottom. Can I get a volunteer to read that note out for everybody? Go ahead, Victor. Thank you.
Your answer should be in terms of pi, which means pi should be included in your answer.
Beautiful. Thank you. So you're going to hear this phrase, a couple times over the next week. Write your answer, quote, in terms of pi. What that basically means is that don't convert it to a decimal. Don't convert to a decimal. That's all it means. It means that your answer should have the letter pi in it. So if we're going to leave pi alone, we're not going to turn pi into 3.14. All we can do now at this point is multiply 4 times 8. What does that give us? 32, right? Times pi equals v. Now, again, we're not going to do anything with pi. We're going to leave it as pi. But whenever we have a number times pi, we always want to make sure pi is on the right-hand side. So we're going to write this as v equals 32 pi. And that right there is the volume of this cylinder. Now, we need units here, don't we? We definitely need units. What are my units going to be? Yards. Have you guys ever learned about volume before? Is this the first you're hearing?
Is it yard squared?
You've learned about it before? It's not going to be yards squared. It's going to be yards cubed. Exactly. Take a look at this shape. How many dimensions does this shape have? 3. It's a 3-dimensional shape. So our units have to have a 3 on them. 32 pi yards cubed. Or you could technically say 32 pi cubic yards. Now, that doesn't really make sense, right? We can't really visualize what that is in our head. So we can always type in 32 pi into our calculators. If you can see it, there we go. And we can get an approximate that this is about equal to 100 cubic yards. Now, volume is kind of tricky because it's hard to wrap our mind around this idea that we can fit 100 cubic yards of whatever, water, let's just say, into this cylinder. I mean, sometimes it can be easier to visualize because it's 3 dimensions and we live in a 3-dimensional world, but it does get a little bit tricky. And I'm just going to say here, this is about 100 yards cubed. Now, you're not going to have to put it as a decimal. Maybe we will. I'm not sure.
Oh.
We don't have calculators, though, so it's kind of hard.
Hey, Mr. Church,
Yep.
can you repeat how you got that 100 again?
Yeah, we just plugged in 32 pi into our calculator.
Okay.
Yep. 32, we can even do 32 times 3.14, and we get a close enough answer. Obviously, the decimals are a little bit off because we cut pi off after 2 digits, but we get the same kind of answer. What questions can I answer about this process? We got to square the number, multiply the height by that new number, and that's basically all we're doing. So as long as you can follow PEMDAS, you'll be good to go. Let's take a look at our worksheet.
Mr. Church, can you use the restroom?
Yep. So here's worksheet 63. Oh, I just realized I messed up. That's not supposed to be 10.1. That's supposed to be 13.1. Either way. Hold on, guys. Hold on. In each of these cylinders, you're going to be given a very clear radius and a very clear height. All you have to do is plug in R and H into this formula and solve. Every single one of your answers should have the letter pi in it and yards cubed. Or not necessarily yards, but whatever the units are. Kilometers cubed. Inches cubed. Like that. Max?
Is there a math?
What's that?
Is there a math?
Yes, there is.
Okay.
But again, this is not that bad, hopefully. If you get stuck or need help, just raise your hand. I'll come by and help. We do have 25 minutes, though.